microwave devices and tunnel diode. Any device capable of generating, amplifying, modifying, detecting or measuring microwave or voltages having microwave frequencies are called microwave devices. Microwaves are a form of electromagnetic radiation with wavelength ranging from about 1 meter to 1 millimeter with frequencies between 300 MHz and 300 GHz. Microwaves are good for transmitting information from one place to another because microwave energy can penetrate through haze, light, rain, snow, clouds and smoke. Basically, microwave devices are used for the purpose of generation of the signal as well as to amplify the signal. Before having the inventions into the microwave semiconductor techniques, it was the vacuum tube devices working for the same type of applications. But the conventional vacuum tube like triodes, tetrodes and pentodes are less useful signal sources at the frequency above 300 MHz. They were not handy. The power consumption is very high. There are many reasons for that conventional tube cannot be used for microwave frequency or high frequency. In the late 1930s, it became obvious that some effects like electron transit time, inter-electrode capacitance, lead inductance limit the operation of vacuum tubes in the microwave frequency band as wavelength becomes comparable to the physical dimensions of the vacuum tubes. The inter-electrode capacitance and lead inductance effect are of the order of 1 to 2 picofarad and 15 to 20 millihenry respectively. The shunt impedance due to inter-electrode capacitance become very low and series impedance due to lead inductance become very high at the microwave or high frequency, which makes these tubes unstable, where the transit time is basically time taken for movement or transition of electrons from one electrode to another. It depends on the distance between electrodes and the effect which is caused due to transit time is known as transit time effect. Possibility of microwave generation by utilizing transit time effects together with lump tuned circuits was suggested by scientists A. Hale and O. Hale in 1935. In 1939, the scientists W. C. Hahn and G. F. Metcalf proposed the theory of velocity modulation for microwave tubes. 4 months later, scientists R. H. Varian and S. H. Varian described a two-cavity klystron amplifier and oscillator by using velocity oscillation. In 1944, R. Kaufman invented helix-type TWT traveling wave tube. Now we can discuss types of microwave devices. Basically, these are of two types: microwave tube devices and microwave semiconductor devices. In microwave tube devices, klystron amplifier and traveling wave tube came, while in microwave semiconductor devices, backward diodes, gun diode, impaired diode, Schottky diode, tunnel diode, varactor diode, transistors and integrated circuits, etc. First, we discuss about microwave tube devices, klystron amplifier. The klystron is a device for amplifying microwave frequency signals that achieve high levels of power gain by applying vacuum tube principles. And the concept of electron bunching klystron are used in satellite systems, television broadcast and radar, as well as particle accelerators and medicine. Klystron can be used in ultra-high frequency region up to 400 GHz. There are several types of klystron amplifiers. One major type is reflex klystron, which is used primarily as an oscillator. The simplest klystron tube is the two-cavity klystron used as an amplifier. The diagram of two-cavity klystron is shown here. The two-cavity klystron utilizes an electron source, anode and a cathode, like a conventional tube. It also have a collector element at the end of the electron stream. The heater, when heated, and the electrons are ejected from the cathode and accelerated towards the anode due to the high DC potential between the two elements. A focused beam of electrons thus produced. In this tube, there are two microwave cavities, resonators, the catcher and the buncher. When used as an amplifier, the weak microwave signal to be amplified is applied to the buncher cavity through a coaxial cable or waveguide, and the amplified signal is extracted from the catcher cavity. In the case of two-cavity klystron, the electron beam passes through a central hole in the first cavity and through a similar second cavity terminating at the collector. Next is traveling wave tube. It is a specialized vacuum tube used to amplify radio frequency signals in the microwave range. There are two main types of TWT. Low power helix TWT occurs as a highly sensitive, low noise and wideband amplifier in radar receivers and measurement equipments. High power coupled cavity TWT are used as a power amplifier for high power transmitters like preamplifier for crossed field amplifier CFA. Traveling wave tube diagram is shown here. It has a cylindrical structure which contains an electron gun from a cathode tube. It has anode plates, helix and a collector. RF input is sent to one end of the helix and the output is drawn from the other end on the helix. Now we came on next topic, microwave semiconductor devices. Backward diode. The backward diode is made of gallium arsenide semiconductor. The abbreviation for the backward diode is BWD. This diode works at low input power and it provides the high output power. This diode is used up to frequencies of 2 GHz. It is one of the microwave semiconductor devices which are used as an oscillator and mixer. The symbol is shown here. Next is gun diode. It consists of only N-type semiconductor, in which electrons are the majority charge carriers. The semiconductor material used for the gun diode is gallium arsenide or indium phosphate mixed with silicon. Its frequency range is from 4 GHz to 100 GHz. It is the microwave semiconductor diode which is used as an oscillator, sensors, measuring instruments and radio armature. Symbol of gun diode is shown here. Next is impact diode. The abbreviation of impact diode is taken from word impact, avalanche, transit time. Alternating signal is generated simply by applying DC supply. The higher range of frequency is 200 GHz. This diode is used for alarms, radar, detectors using RF technology. The symbol is shown here. Here is cathode, here is anode. This region is known as avalanche region. This region known as drift region. Schottky diode. The frequency range of this diode is from 3 MHz to 10 GHz. This diode is used for switching and mixing purposes, voltage clamping and discharge protection power supply also. The diagram symbol is shown here. Tunnel diode. The frequency range of tunnel diode is up to 100 GHz. A tunnel diode is a microwave semiconductor device which is used for oscillation, amplification, mixing and switching purpose. Symbol is shown here. Corrector diode. This type of diode changes its capacitance with the change of the bias applied to it. The frequency range of corrector diode is up to 105 GHz. Corrector diode is mostly used in television, FM receiver circuits, voltage controlled capacitors, and in FM transmitter circuits. Symbol is shown here. Transistors. The conventional transistor cannot be used for the microwave frequencies because of its low efficiency and high distortion. The field effect transistors FET, made of gallium arsenide semiconductor material, is used for this purpose due to its efficient energy band for very high frequency. We use these transistors for the purpose of amplification of the high frequencies. This is diagram of P-channel feed effect transistor, and this is diagram of N-channel feed effect transistor. Next is integrated circuit. As the inductance and capacitance for the high frequencies is supposed to be very small, therefore the physical size of inductor and capacitor becomes as small as possible at very high frequencies. So the hybrid integrated circuits can be easily manufactured for the purpose of microwave frequency. The diagram shown here of different type of ICs.